are you, my friends? In this video, I'm continuing the algebra course, and this is lecture 28, graphs of functions. We will graph some basic functions, and also we will look at greatest integer function and piecewise functions. So the objectives here, graphing basic functions. We said also piecewise, we discuss how do we know the graph if it is a function or not by vertical line test and also by equations. Just a simple idea here that if we need to graph a function, we have to get set of all ordered pairs, x in the domain and f of x from the function itself. I will present here 8 basic functions. So you can see and read, please. The first one, we call it identity function, straight line, x squared, x cubed, square root of x, cube root of x, absolute value of x, 1 over x, greatest integer function. So this, you have to know the equation, you have to know the name, and you have to know the graph. Let's start one by one. Most of them are easy because we call them basic functions. Here I put all the graphs together, 1, 2, 3, 4, 5, 6, 7, 8. Just on one slide, you can see the number of the function, the name of the function, the equation, the graph, and then we'll go and do it in details. So the first one is the identity function. Just take some points. If you take 1 and 1, 2 and 2, 0, 0, that's a straight line. F of x is equal to x. Domain will be all real numbers and the range will be all real numbers, the values of y. The function is increasing on the entire domain. See, it's going up on the entire domain. Second one is also easy. Quadratic function x squared, we have seen if you take x equals 0, it will be 0, plus or minus 1, it will be 1, plus or minus 2, it will be 4. Just take some values and you know this is parabola or quadratic function or square function. So there are 3 names for this. F of x is equal x squared. Domain all real numbers and the range are the positive values including 0 closed to infinity. See this one we can see decreasing from minus infinity to 0, increasing from 0 to infinity. So there are 2 parts here. Now the cubic function or cubing function, same, y equal x cubed. These are some values table, so simple. Take 0, take 1, it will be 1. Take 2 here, it will be 8. So 2 cubed will be 8. The domain, all real numbers, this is a polynomial function. And the range also all real numbers. It's all increasing on the entire domain. I'm going a little fast because these are simple and easy, but you have to remember the equation, you have to remember the graph, you have to remember the name. And then after that, in the coming lectures, we will make shifting on these functions. That's the important part. So you have to remember all these basic functions. Basic function number 4. Square root function, f of x is equal to square root of x. See, we call it also half parabola. Square root of x means y equals square root of x, so y is positive. Also including 0. If you put x equals 0 from the domain, y will be 0. So the domain will be the positive values of the x because under the radical, the radicand should be greater than or equal to 0. That's 0 to infinity. And also the y is equal to square root, which is positive. So y will be also the values of y from 0 to infinity. This is the graph. It is increasing on the entire domain. Cube root function, cube root of x. Take x equals 0, x equals 1, it will be 1. If you take x equals 8, it will be 2. And then you graph it. This is the graph of the cubic function. Domain is R, and the range also is R. It is increasing on the entire domain. Number 5. Number 6 is the absolute value. Also, we have seen absolute value where we have a V shape. So easy to plug in some numbers, domain or real numbers. You can put x equals 2, x equals 3, x equals -2, -4, -5, -6, -7, and the range all the positive values of the y, including the 0. Decreasing, see the function is decreasing here from -infinity until 0, open, and then increasing from 0, open until infinity. Number 7 is the rational function f of x 1 over x. 1 over x in the domain here, we cannot accept the 0 because 1 over 0 is undefined. So domain will be all real numbers except 0. Another way we can write it, -infinity to 0 open, union 0 to infinity. And the range is the same also. You can write this as R except 0, or you write in English all real numbers except 0. This is decreasing and decreasing also in these two intervals. See, the function is decreasing and decreasing. Number 8 is the most difficult, I think. Just look at the shape of the function f of x, 2 brackets there with x. So this one, we call it the greatest integer function. It means the greatest integer less than or equal to x. Remember, less than or equal to x. So if x is 2.7, it will be, the y will be 2. If the x here is, let's say, 5.69, it is 5 less. Minus 1.2, the value of y is -2 less. Okay, suppose we need to graph now the function. So I can take x equals 0, y will be 0. So I put it there, you see, x equals 0, y will be 0. X equals 0.5, y will be 0 because less than that. So still we have another point there. 0.75, then it will be 0 again. Until we reach 1, the image will be 1. See, it goes up there. Now, if we go to 1.5, it will be also 1. So x is 1.5, y will be 1. If x is 2, it goes to 2. So if x is 2, it goes to 2. And then we continue like this until we reach like stairs. So this is the graph of the greatest integer function here. See, here we have an interval from 0, you can see that here, from 0 closed until 1 open. All these x's, the y will be 0 here. From 1 closed until 2 open, all the values of y will be 1 because 1.1, 1.2, 1.5, 1.7, 1.8, all it will be 1. If we come to 2, the image will be 2. So it's like stairs. Now, if you say the domain, all real numbers, because we can replace here any x. Now look at the range. The range only the integers. So in the range, we don't have a fraction. It's 0, 1, 2, 3, 4, -1, -2. See, -1.5. Let's see here. See, -1.5. It's -2. We need the number less than. -2.5. It's -3, etc. Now, let's take an example here. If we have a greatest integer function, 2x minus 0.5 minus 3. Find f of 2.5 plus f of -1 divided by f of pi minus f of 10. We have to add and subtract, then we divide. Let's go one by one. If we understand the first one, the rest will be easy. F of 2.5, so I put here in the x 2.5 times 2 will be 5 minus 0.5 will be 4.5. Now we take the greatest integer after we have only one number there. So that's 4. 4 minus 3, so here the image will be 1. Now we continue the same way until we get all the numbers. See, as I explained here, f of 2.5, multiply this x by 2 from the function, simplify the greatest integer here becomes 4, and 4 minus 3 is 1. Now, put minus 1, see here, minus 1, we need f of minus 1. Minus 2 minus 0.5 minus 2.5, the greatest integer less than that, so it's minus 3. And we have already minus 3, so it's minus 6. F of pi, I put pi 3.14 in the x, so that's 6.28. Minus 0.5, it's 5.78. So the greatest integer will be 5. 5 minus 3 is 2. Same thing, I go for 10. Then I put the numbers, and this is the answer. Now, there is a nice and important formula about greatest integer function. If the greatest integer function of x is equal to n, remember n is integer, then x between closed n, greater than or equal, less than, which is open, n plus 1. Now, x can be an expression, remember, like 2x minus 1, x plus 7, etc. Let's give you some examples here. So if n is 0, put here 0. N is 0, that means all the x's will be closed from the graph here, all the x 0 until 1 open. See n plus 1 here, 0 plus 1. This is on the right side. Now, if n is 1, put the image here 1. What will be the x? 1 closed until 2 open. And this 2 is coming from 1 plus 1. See, anytime you have an n, let's say 7, so you put here 7, here you put 8. Less than, here less than or equal. And you put the expression there. See, if you take minus 1, let's say minus 1, n is minus 1. Then x between n is minus 1, n plus 1 will be 0. Same thing for n minus 2. Let's look at this nice question. Given the function 7 minus 1 over 4x, we need the values of the x such that f of x is equal to 3. So that's the image now. See, 3 is this n here. You see this n here? That's the 3. And we need the values of the x. From where to where, we get 3. So f of x is equal to 3. That means n is equal to 3. Apply the nice formula. All the expression we have, which is 7 minus 1 over 4x, between closed 3, open, 3 plus 1, which is 4. Now, we go back, this one to compound inequality. We need to solve it. So we subtract here 7, so minus 7, minus 7, minus 7. And then we multiply by minus 4, because we need x, remember, to change the signs. Then rewrite it, x greater than 12, less than or equal to 16. This is the x value, open 12 to closed 16. This interval will give us the image n equals to 3. Now the vertical line test. What is a vertical line test? It's a test. We test the graph. Just give me any graph, simple, easy, difficult, function, relation, any graph. Look if this is a function or not function. Draw a vertical line. If it cuts only in one point, it is a function. So no vertical line intersects the graph at more than one point. Now this one here, if you draw a vertical line, it cuts the graph in 2 points in the vertical line. So this is not a function, and this is a function. So easy, by looking, you can check. Now which one of these are functions here? This one, you draw a vertical line, draw a vertical line, draw a vertical line, draw a vertical line, you can check. This is yes function, no not function, no not function, yes function. So from this you can remember, like straight line is a function, circle is not a function, etc. How to test an equation? Suppose we don't have the graph, we have only the equation. So easy. Take any value for x in the domain, replace that value in the equation. Check if you have one image and the y or more than one. See, like this one, we have three examples here, A, B, C, in example 4, 3 parts. X squared plus y is equal to 1, y squared plus x squared is equal to 10, 3x plus y is equal to minus 4. Let's see if the first one is a function. Now, suppose I said here, we have the equation, we don't have the graph. If we have the graph, it's easy. But this method is faster if you have the equation. Just take any x you like from the domain. Any x you like. I took here minus 3, square it. See, squared here. 9, take it on the other side, minus y. So we have only one value for y, that's a function. Second one, let x equals 2 or minus 1 or 7, whatever the number there. So put it here 4. So y squared will be 6. So we have 2 values for the y, which means 2 images. So not function. So circle is not a function. This is a straight line. It is a function. Let's look now at example 5, which is very important question because we need to graph a piecewise defined function. There are 2 pieces here. F of x is equal to 5x plus 3. If x less than or equal to 0. Minus x squared plus 4 if x between 0 and 2. We need to find the domain, the range, and where the graph is below the x-axis. So the whole idea is to graph it. So when you graph a piecewise function, you can take the graph into pieces. Let's look at the first piece here. 5x plus 3, x less than or equal to 0. So you write it in the left here. Take some points. If you take 0, because it's closed here, 0, it will be 3, so 0, 3 there. Take minus 1, put here minus 2. So minus 1, minus 2, there is another point. Join the line. That's it. You cannot go beyond 0 because it will be x less than or equal to 0. If you need x-intercept here, see there's an x-intercept. Let y equal 0. So put y 0, x will be minus 3 over 5. This is the number here. See, minus 3 over 5. Let's take the second piece. X between 0 and 2. See, I take 0 here, but remember I put open. I put 0 there, minus 0 squared plus 4. So 0, 4 is open. I cannot start with 1 or half. Start with 0, open, remember that. Then take 1 including there. So minus 1, this is 3. Take 2, it will be 0. So this is a half parabola, see? But we stop at 2 closed. Here, we start from 0 open. That's the part here. So this is like, you know, this is half parabola, but this is part of it. Now look at the domain. Domain from minus infinity until 2, because this one is already closed here in the 0. This 0 here, there, x equals 0 is there. Also, you can get the domain from the given. All the negative and also including 0 until 2. So minus infinity to 2. Range will be from minus infinity down on the y until we reach 4, but open 4. See, 4 is open. Now, the question, where the graph is below the x, this is on the x. Below the x from here. See, from minus infinity until we reach this point, which is the x-intercept here. So minus infinity to minus 3 over 5. Please study this question again. So nice. And then you can see the old exams questions to practice. The greatest integer here. Number 2, which of these is a function? And then graph this one. This is similar to our example 5. This is a piecewise. State the domain and the range. Find x-intercept and y-intercept. Very nice to practice. Then there's another also piecewise, x squared, absolute value less than 1. Find the domain and range, etc. Which relation does not represent a function? And also another piecewise function graphs where the graph is below the x-axis. Just please practice. These are the answers, only the answers. If you need the complete solution, please go and see all the exams questions, graphs of functions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is lecture 28, graphs of function. I hope I can see you in another video with another topic. Thank you very much.